In this episode, we're going to start off with cleaning up the back end. Dog owner joke. Last time, we gave our dogs a proper place to store their data. Postgres running in Docker, wired up with SQLX, and real migrations. Today, we're leveling up again. We'll complete our CRUD API for dogs and feedings, refactor weights into a proper time series, and even prepare our app for real-world development. That means adding new endpoints, refactoring our schema, introducing a stub user interface, and wiring the whole thing together with Docker Compose. We're moving our app to the next level, getting to a point where we can consistently deploy our app end-to-end. I'm Chris. Welcome to Coding with My Dogs. Welcome to Byte Size, the easily digestible nugget of information that's tangential to today's topic. In this segment, I want to introduce macros in Rust. Macros are effectively code which either generates code or transforms code. They can get quite complicated in Rust, with procedural macros able to translate the abstract syntax tree from one block of code to another block of code. That's how things like the tuck.io main declaration work under the hood. These, however, are way beyond the scope of what we can handle in an 8-minute segment. So instead today, we'll look at the other type of macro, declarative macros, and we'll work through a few examples. So here we have the simplest type of macro that we can generate here. And you can see how how declarative macros get defined by using this macro within a macro. So you define the macro rules, you give the macro a name, and then it basically has this block below it, and effectively it takes in some arguments, none in this case, and then between the curly braces here is the code that will actually get inserted when you call this macro. So basically what's happening is when you see something like this, when the macro gets expanded, it's basically removing all of that and replacing it with that section there. And that's how the macros work. And then you can see from this simple example, you get the output there from that main function. Now, in most cases, you wouldn't want to declare a macro like this because it doesn't really do anything useful that you couldn't do within a normal function within Rust. And that's quite an important distinction. You know, macros are there for code generation, but there's only like certain cases where you'd want to use something like that. In general, you would just use the normal program flow, and that gives you, the full capability of stepping through the code, debugging it, etc. Macros are much more of a specialist case, but we'll have a look at some examples later, which will show some of the power that you get from macros that you just couldn't get by writing a function. It's just not possible. So here's a slightly more complicated example. We can see in this one that the macro takes an input, takes input arguments, and you can see how the sort of, the macro variable naming works with this dollar syntax here. And therefore you can see that when this macro is called, whatever is passed in as $x is translated to the code that is just $x multiplied by 2. And therefore when this is called in the main function, we would expect to see 21 times 2 being what this expands into, and obviously that's the result that we get. So that's a slightly more complicated example, but we can go further. So this is showing how the vec macro that's used in Rust actually works behind the scenes. So with macros, you can pass in an expandable set of parameters. So in this case, what's happening here is we were saying that for the overall set of parameters that get passed in, we have this one here, which can be repeated 0 or many times, which is what this indicates here. And therefore, when we expand it, we can say, we can put in normal lines of code like this. So we're setting up this mutable vector that we will be pushing items into. And then you can see this special format of code here, which tells us that we want to repeat this line of code for each of the elements in this sort of .x array, if you call it that. And therefore, for each of these elements, it's going to add one of these lines in where we are pushing that element into the array. And at the end, we are returning the value of the array that we get created. So therefore, you can see, exactly as you would use the normal vecbang macro, when we pass in this set of 3 items, the output is going to be a vector that has those 3 items, 1, 2, and 3. Now, for this final demonstration, I'm going to show something that shows a little bit more about the power of macros, what you can potentially do with them, and something that you just couldn't do directly with code. So this one here is a macro which will be used to generate a struct which has a number of fields within it, and each of those fields is of the same type. So you have a name that the struct will take. We have the type that it will take. And notice that these are sort of special things for the definition of a macro. So this is an identifier, and this has to be a type name. And that means that there's a little bit of checking that can happen there. And then again, a list of identifiers for each of the field names. And then this is saying that there has to be at least one to many, not one to many relationship, but one or multiple instances of that field can be defined. And then you can see the power here. We can automatically add the derive attribute to the top of it. You define the struct that has that name. And then again, going through that list of fields, it defines the field within the struct itself. So the field name and the type that the field will have. And we can see a couple of examples of how that could be used. You could generate a point class there that is has X, Y, and Z, so 3D coordinates with I32, or you could change that to float if you wanted to have a floating point version. And then we can define one that has no point. It's just X, Y, and Z, and each of them is unit, so it has no value for each of them. And then showing just what happens there. So effectively, this happens before the main routine because these are effectively expanding into type declarations for the structures. And then within the main routine, we can then initialize each of these structures in the same way that you would do if they were just defined in the normal way. And then finally, you can see what happens there. We are printing out the result of the initialization of those 2 points, or the point and the no point types. That's just a taster of the world of Rust macros. As I said before, you don't always need to use macros. If you can achieve the same using just normal functions or generics, then you should definitely do that. But as you can see here, even declarative macros are pretty powerful for certain use cases. But that's enough with macros today. Let's get on with today's coding sessions.
Right. So in this first session, we are going to just finish off the API. There really isn't much to the API at the moment, so we need the full set of CRUD operations. What do we do to add a new dog, to delete a dog, to add new feedings for the dogs, to remove feedings from the dogs, to basically be able to change anything around that we want. And the other thing I want to do is that currently the dog's weight is just a static field within the dog record itself, and there's no history for that. So instead, I want to add a time series for the dog weights for each of the dogs, so we can go back and see, the date that the weight was taken and the trend of the trend of the weights for that dog. So yeah, we're going to need to add a new database migration because we need to add a new table to track the dog weights. So let's bash out some code. So first of all, let's add a new migration, which we can use for the weight time series table. Just migrate, isn't it? Okay, helps to read the error message. So there we go. There's our new migration. And what we want to do is, if we have a look at the first, we've got our table dogs, which has weight within it. We need to update or alter table dogs and remove the weight from dog itself. Instead, what we're going to have is that whenever we want to fetch the current data for a dog, we will take the latest weight from the time series by date and use that in the record that gets returned. So we don't need to have it denormalized within the dog record itself. So let's get ahead and do that. So we need to alter table dog. So have a table dog weights, like so, which will have date, and we'll also need to bring in the dog name primary key like that, or dog name foreign key, I should say. And we also need an ID. So let's just copy all of that across so that we know where we are. So ID. There's no name or breed. The weight ID, the date of the weight that we take, and then the dog name, which is then used for the foreign key constraint, which references dogs by name, and our dog weights primary key, dog weights. So, and dog weights name for the foreign key constraint. Our dogs, dog weights, this is the table name, isn't it? Dog weights. Name, and yeah, that gives us what we need for the new dog weights table. And then we just need to do the alter table. Dogs. Delete column, is it? Drop column. So we end up with dogs that does not have a weight, and we have the dog weights times series. And we'll also need to just insert some weights for the existing dogs so that everything stays consistent and the API still works. We don't break. Obviously, we're going to need to make a small tweak to the API because when we get the dog, we now need to make sure that we fetch the latest weight from the table instead of just taking the record itself. Okay, that ought to do it. So we are selecting from dogs the weight and the name and using current date and then inserting that into dog weight. So we should get 2 records in dog weights with the current weights of the 2 dogs. That makes sense. Okay, right. That's probably correct. I need to make sure my database is spun up. There it is. That's running. So I now need to apply those migrations, test that it works. Down in the terminal, we can use SQLX migrate run. And that should apply those migrations. Make sure it's saved first. Okay. Just like that, it says it's done. So let's look at the Beekeeper Studio. And we can see we have the dog weights table. 2 records. Exactly as expected. References back to T-Dog and CS-Dog. And if we look at the dogs table, it no longer has a weight column. It's just name, breed, date of birth. Brilliant. That's the database updated. Of course, we now need to go and make sure that within the application, the dog record is updated so it understands that it doesn't have a weight. And then we need to update the endpoints, which are bringing back the dog data, to make sure that they will then go and fetch the current weight for each of the dogs that they need from the dog weights table. So let's crack on with that. So here we are in dog. First thing we're going to do is just delete the weight. That's going to break everything, which is fine. Move fast and break things. So that's something broken. Already issues here because we've got a couple of tests that relied on that, which we can delete, or we can delete the column that they rely on. And that is good. That's fine for dog. And then we need to go into our handlers, because clearly that's not going to work when we are updating the weight for a dog. That's definitely not going to work. What we need to do here is change that SQL query to say we are inserting into the dog weights table. So it's kind of like what we did here, except we're not going to do this select. We are instead going to directly add the weight that we retrieved. So let's do that. So let's copy that across. Let's put this in. We are inserting into dog weights, date, weight, dog name, using the current date, $1 parameter for the new weight, $2 parameter for the dog's name. That should be okay. Save that. And it is happy with that. That's good. So having updated the weight, it knows if the dog wasn't found. That's not going to happen. What we're more likely to get is a foreign key constraint error if the dog doesn't exist. Let's not dwell on that at the moment. I will need to do that at some point, but for the time being, instead, let's do this. Let's fix these errors up here. Right from the start, this is not going to work. This dog with feeding row is joining the two tables together. And there isn't a weight for the dog anymore, which is fine. We bring that back when we need it. Oops. So doing the same thing it did before, except we don't bring back the weight at the moment. What I'll do, I'll just make sure that these endpoints work without the weight, and then we'll cycle back to them and add the extra bit that's required in order to go and get the weights looked up from the latest record in the dog weights collection. So that was the get all dogs, and then kind of similar for get dog. A single dog, we still don't want to bring back the weight, doesn't exist. And again here. So that is fine. If we do a cargo run, that should work. And let us hit our endpoints again. So to get all dogs, they come back, they just don't have a weight. Nice. If we're just getting T-dog, same thing. And what I'll do then is we will update 38 I wanted, 38 T-dog's weight, like so. We'll do the same for CS dog. And that should give us two records to play with. Okay, we've got a problem here. Whilst we wouldn't necessarily weigh the dog more than once in a given day, I would like it still to support that. So at the moment, we've just got the date. And obviously everything's going to be the same here because I've just done the migration and running that test on the same day today. So I need to change that to be a date time and find out what we need to do with that. So yeah, so what I'll do, I think I'll probably update this migration, and then I'll go back and recreate the database from scratch to apply all of the migrations and then get us back to this correct state, but with date time. No, type date time does not exist. Okay. Okay, apparently we have two options here. We have timestamp or timestamp Z. Timestamp is just a raw date time timestamp with no location information. Timestamp Z is one that is referenced from, I guess, Zulu time, so UTC time. And that's, maybe you could argue that that's overkill for this application, but I think for anywhere where you are wanting to record a timestamp that might later get compared to other timestamps that may have been created in different locations, but you still want them to be able to understand what thing happened first, what thing happened later, then you should always really normalize to something like UTC time. So we'll use timestamp Z for that. And then you can use current timestamp to insert a value for the exact current time into one of those fields. That's not promising. My bad, it's timestamp TZ, not just timestamp Z. So timestamp time zone, which makes more sense. But again, it's normalized to UTC time. That's the way that this works. So that should hopefully work now. Let's try one more time. Great, that migration got applied. We'll check within Beekeeper Studio. That's great, showing us the current time as Zulu time. So I can run the application up again. Reapply those changed weights. Refreshes at the bottom, there we are. And there we can see that it didn't work because we are generating our time differently. Okay, so that was the one that was created directly with the SQL statement. This is the one where we are inserting the time and we're clearly just using a date, not a date time here. So again, from within Rust, we need to kind of do the same thing. We need to work out how to get a timestamp that is UTC time and insert that instead. Delete row and apply. Good, good, good. Back into here. In our handlers, we are inserting okay, yes, so I forgot. It was done by SQL, but we need to use current timestamp, the same as we did in the migration. Okay. One last try. And that looks better. You can see the two 5 minutes apart. And that means that when we want to query for the latest, it's always going to work. Even if we have many different records added in the same day, it's going to choose the latest weight every time. So let us go and let's look at the single dog for the moment. I deleted weight from dog, whereas dog is the domain type. It's not really the DTO for the database. We kind of don't have a DTO. It's just dealt with in these handlers by the SQL. Obviously, we still need to have weight as a field for the dog, but we start off with that weight being undefined. And then as the database, as we fetch that data from the database, we can then update the dog record to add that weight. So let's have a look at a clean way of doing that. So I'll put back in a current weight field. I'll need to go back and fix those tests because they want to have that. So that fixes dog, does it? No. Back at the handler, we are going to have to do something different here. So we've just been using the domain types here to load data directly in from the database. And that's not typical for when you start to look at the design of an enterprise grade application. What you'll tend to do is that there will be types specifically to represent the movement of data. So the transfer of data from a database repository into a domain type. There will be a database layer type. And then when you're transferring from the domain to what comes out from an API, typically it will be a DTO, a data transfer object, to represent what the API specifically returns, and that's decoupled from the domain. And the domain object is like the source of truth for everything that's running when it's running within the application. So what we can do here is, as we did with, let me remind the name. So dog with feeding row, we can have a dog row to represent a dog row within the database. And then that doesn't need to have, will not have the weight within it. But we can use that to fetch the dog back in the handler. We can then fetch the feedings separately, and then we can fetch the weight separately, and then combine all of those into the domain type that then gets returned. So let's do that. Let us copy and paste that. We will call it a dog row. There's the name, breed, date of birth, and doesn't need any of those. In fact, what am I doing? So we're bringing this stuff back as dog with feeding row anyway. So we probably don't need this, but what we just need to do is to restructure the way we're doing that handler implementation. So we don't want to be building up a mutable dog here. No. What we want to do is right at the end, we will create a dog that is not mutable. And we'll put everything into it at that point. So up here, we need to say, let mutable feedings equal feedings, which is a vec of feeding, equals vec bang empty array. Like so. Sorry, I don't know why I put the brackets around it. And then for here, we can just say feedings.push. So that builds that up. And then feedings here is the feedings that we brought in, that we've just built up there. And then finally, we can say we need, in fact, we could just join here. So this is one of those situations where, as you go through the code, you can work out ways that you want to improve things. And I think one of the things that I want to do here is to say, we may as well do all of this in the join, so we can update the dog with feeding rows to also say dog with feeding rows and weight, and then update the SQL join that we're using for this to bring in the most recent weight for the given dog as well. So let's look at that, and that makes this all clearer because we only need to do one hop to the database, and then we can combine all of that data together in this one method and get the result that we want. Let's do it. So I'll try this out here in Beekeeper Studio, joining into dog weights on the dog name matching, and is it recorded at? Just date. As the maximum of the recorded dates for that given dog. So let's run that. And that looks good. Yeah, that looks like the weights we were expecting. So that's tested. So I can copy this across and then use that. I can use this now within our SQL in the handler, and then it's just a matter of updating the aggregate type that we created to have a field for the current weight as well. Okay, cool. Starting to pick up on how Rust works, so that's good. So we're only taking a reference there, and we're just making sure that for these feedings, we're not using any types that are defined within that row itself. And that means that when we come to the dog, setting up the dog here, there's no problem with that. In fact, we can probably, can we get rid of the clone here? Because it no longer matters. This is the last time we refer to it. Guess not. Yeah, and the reason for that, obviously, is we are... I mean, we're not returning the dog itself. We're returning JSON that comes from the dog, but I guess maybe the compiler doesn't really know that, so it just needs to know that it can dispose of rows and it can dispose of the dog as separate things. I guess maybe the string gets still used, and that's unlikely, but I guess it's just being overcautious with some of these things, which is fine. So that gives us the current weight, and that should be fine for get dog by name, but we need to do the same change up here for get all dogs. And just to remind myself here that when we as we step through each dog, we are then initially adding it to this hash map. If it's not already there, if it is there, we bring it back. And then as we step through each of those rows, which are denormalized, of course, we then pushing the feedings into that as well. So we can do the same thing here. We can go and grab that extra bit of SQL that gives us the additional join. Error. Yeah, syntax error near current weight. So it doesn't like that. Why don't we just try in Beekeeper Studio? Schema DW does not exist. Okay, so it's that way round, and that's why it couldn't work out what DW was. So the as keyword is correct. It just doesn't need quotes around the table alias, column alias that I'm using. So great. Hopefully we can sort that out quite quickly. Current weight. Oh, there it is. That's current weight. Save that. Restart this. Try one more time. Maybe it's just the formatting. Probably the fact that I brought it there instead of like so. Where clause needs to be the last thing because obviously we are joining before that point. Okay, excellent. And it has brought back 38 and all the feedings are there as before. And if I run that for both dogs, all dogs, we get CS dog back with 39.5, which is the latest recorded. Brilliant. Okay. So that's that nice little bit of refactoring done. And we are now ready to crack on with adding some more endpoints. Okay. Mr. T. Mr. T. Hey, don't lick yourself there. Mr. T. Here we are. This is what we're going to do today, okay? So we've got our application at the moment. It's got a separate database. And the API connects to that database, okay? See like that? And what we need to do today is we're going to slightly refactor the API. It's not holding too much interest to you, is it? And then we're going to move the database into a container. And then we move the API into a container. And then we'll create the first part of the user interface. And then we'll put that into a container as well. And then
Finally, we can use Docker Compose to take all of those and be able to start and stop them all together with the user interface and the API and the database all connected. How does that sound? Oh dear, you've fallen asleep again. Okay, may as well get coding.
Okay, next we want to just do a little bit of cleanup here. We've got a few things that are causing warnings when we do the cargo build. And then we just want to add a couple of new endpoints to cover, some of the new stuff like adding the time series for weights and just general CRUD operations around, being able to create a new dog, delete dogs, delete feedings, that sort of thing. So what we'll do is just start off with a little bit of that and then speed up the footage so you don't have to watch every single little bit that I'm adding, which is just a bit of repetition compared to what we've already done. So let's bash out some code. So firstly here it's complaining that shared dogs isn't used anymore. That was the alias that we created just to deal with the in-memory state. So we can just go there and we can just delete that entire thing. Just a few unused imports. More than a few. Let's go and deal with each of those in turn. Yeah, I guess that was because our day one data was previously defined in here and it's not used anymore. So let's just get rid of all of those. That looks a bit healthier. I don't know why it's suddenly complaining about connecting to the database. Remove that unused using. Okay, of course the shared docs module isn't there anymore, but we don't need it. So let's go there and delete that. And that shouldn't be needed. Ah, dear. Using it in more places than I realized, but that's fine. Is that the last one? Excellent. So clean build. What I want to do now is just run this and see, do we actually have connection to the database from here as well? So I don't know why it's complaining in the code that it can't connect to the database. So let's just try here. Where is our localhost.rest? And let's just get all dogs. Fine, no problem. So that's connecting. Yep, I don't know what's wrong there, but we'll ignore it for the time being. So into handlers. Next up, we need to get the weights time series for a specific dog. And we don't have a domain type for that. So just to remember the weight time series we have time series ID. The date, which is this time zone timestamp, and the weight itself. Dog name we can imply because we're going to use the dog name to fetch the time series in the first place. We won't be doing this for all dogs. We'll just be doing it for a specific dog. and we'll order by the date. So let's create a new domain type. Dog weights. Oops, dog weights. Like so. Does this have like a timestamp or? I have to do some research on that in a second. Let's close all the others so it's not triggering my OCD having all of this stuff across the top. So this is dog weight. Yeah. That's dog weight. Each record is an individual weight. It's not a set of weights at this point. Okay. So we wanted the date and the weight and the ID. I want to see what the ID actually is. So let's have a look here in Beekeeper Studio. Captain Scrunch is the highly secure password. Dog weights. So the ID is an integer. That's fine. We can use, presumably, this int 32-bit integer. Okay. That's fine. Presumably an unsigned integer as well. So we can say unsigned int 32-bit. Date. Naive date for the moment, but I don't think that's what we'll end up with. And then the weight itself there, like so. Delete the remaining rows, properties, and that gives us what we need. So ask ChatGPT here. So ask ChatGPT here for the chrono crate, which type best matches the timestamp TZ column type that we have in Postgres. So basically what this is saying is obviously our timestamp TZ internally is a UTC date and time, and it stores the offset for local time where it was originally created. So we have the option within Chrono to retain that we want to know exactly what the offset was when it was created. But we get no benefit from that. And usually what you're trying to do here is just be able to compare the date times from, multiple things that are created potentially worldwide. And the way to do that in a completely robust manner is to use the UTC format for date time. So that's effectively Greenwich Mean Time or Zulu time. So let's do that. I thought. Okay, let's do that. Okay, make it well. And let's do it. Super, there we go. And so that's what's going to and let's copy all that. And we can always get weights, my name, passing dot name. And we are bringing in from this a vec of weight, I believe. What do we do? Let's say, sorry, all. Yeah, just knows that it's a collection of values, so we don't need to set using sets. Each row does weight actively, search fine. So we are selecting from the weights table, one ID, weight, and weight. So those are the particular fields we want to select. We define each of them explicitly rather than just using a star, because that just gives us, belt and braces, making sure that if someone decides to change the database without changing the code, we will immediately see that it is broken rather than potentially having the wrong things serialized into different columns, which could easily happen. So that's fine. We can use the usual thing. Let's save. Okay. Make sure that's brought in. Which it is. That's good. Right. Guess this is the first time we've tried to extract from the database directly into domain type, and that's probably not what we want to be doing. I know it's a lot of repetition, but let us put in here. So we don't really want to define this from row trait against our domain type explicitly, because that is not a separation of concerns. That's sort of muddying the waters in the domain with database specific implementation, which we don't want to do. I mean, the domain types could be in a completely separate crate from the database interaction layer. And we don't want to have that there. So what we'll do here is put in what looks like a complete duplicate of the domain type here, but it just gives us that separation. It shows, this is how we bring back those rows from the database, and then the mapping from that database type to the domain type will happen only within the handler. So let's do that. So here, if we get an OK result, then that dog waits. So we want to map. So wait row. Dog. Oh, it's harder. Still a little down here, so why is it going down? Oh, it's not on this. Fine. Got a bit of time. Okay. Let's read it. Why is it still like that? It can be true. Why is it like that? Anything else? Something I do. Did I do? Give me no guess. You said it too. You know, it's like it's like it. Ah, yeah. Tricking the magic. Interesting. How does this work? Ah, hey, Captain Scrunch. Okay, that was a brief visit. Okay, so we needed to say for the map dot so for the vector we turn it into an iterator first. Like so. Then we map And the format is like this. Dog weight with curly braces should be what we're returning. Oh, yeah, what am I doing? Equals wr.id. wr.date, wr.weight. Oh, sorry. Colon, not equals. Yep. In fact, I wonder, do we care about IDs in the domain type? So the thinking there would be that if we only ever insert a weight or get the set of weights and then convert those to domain types, the domain type doesn't really need to know the ID, which is a database specific thing. It just needs to know the date and the weight. So let's change the domain type to do that. And we can always change it back later if for some reason we do want to do it that way. But yeah, let's make that change. Delete that as well. And this is basically saying we build up this set of dog weights, and then at the end of this, we need to collect it back into a vector. So collect is basically to take the an iterator and to convert it into one of the concrete collection types. And I think by default, that means it'll convert it into a vector, but you could convert it into other things like a hash map or something like that if you wanted to. So that gives us that. So this means now that dog weights is unknown. That can't be true. So we want to return JSON of the dog weights. Like so. So again, we're using the expression style here. So match rows is an expression. So as long as each of these branches resolves to an expression, the whole thing becomes an expression, and therefore it becomes the result from this entire handler function. So again, expression format here, so we don't return, we just end with that and remove the semicolon. Basically, these are the only branches we've got, aren't they? So everything else here is gone. We remove that semicolon because that has to be a return expression. We want into response there. Like so. Type annotations needed. Why? Surely you know that it's a dog weight. I guess collect vec of dog weight will do what we need. No. Comparison operators cannot be changed. Okay. I do it like that. Okay, yep, so it's happy with that. Great. Let's run that and see if we get a result. And we won't get a result because I haven't actually mapped this handler at all. So let's do that first. Okay, dog's name weights and a get, which will do get weights by name. Okay, we've got a new unused import coming. Okay, let's go back here. We have a get off the back of that, and we will click that now. And there we go, the two dates and the two weights that we created. Okay, so looking at this one, this is basically, in my mind, this has changed now because previously we were updating the weight within a record, which was the dog record, and that translates to being a patch in sort of, HTTP parlance. But we are not doing that anymore. We are actually inserting a new record every time we update the weight, which is basically the new weight and the current date and time. So this should change to being a post, not a patch. And we can post to the same route as we use get for. So it's weights. We are posting a new weight into that. And this should probably change to something like insert weight for name, something like that. For name, let's go back to the handlers. Go away. Insert. Wait for name. Like so. You need to bring in post. It doesn't know what that is. And we can get rid of patch up there somewhere. Okay, didn't put in post up there. Axum routing. Let's put it here with the others. Why not? They're random in the order of these things, isn't it? Let's put this with the other Axum stuff. Save that. It's happy. Let's just try that out. And that worked. This is CS dog. And there we go. The new weight comes across. Brilliant. That's good stuff. That's a nice little bit of refactoring there. Also, what I'll do now is just go through this router and add the other endpoints that I'm intending to create for this service. And then one by one, we can go and implement the handlers for those. So let's just do that up front. And we're going to need get, post, and delete. So
Okay, so that's implementing a few new things. As you probably saw there, I decided that obviously when we are posting, what we are posting is the new dog, which will include the name. So there's no point posting to the name itself. You can just post to the dog's collection. And then that gives us consistency over here that when we add a new feeding for a dog, you're posting into the feedings and you'll pass in the new feeding information, which has the time and the food type and the amount. And it's only when you want to delete that you have to specify which timed feeding we want to delete for the given dog. So that's it. We can insert a new dog. We can delete an existing dog, and that delete will cascade delete all of the weights and all of the feedings. For the cascade delete, we have a choice of doing that in the database. We could have set up our database tables to automatically cascade delete when you delete the dog. Or, as we'll do in this case, we can do that in code so that when the endpoint to delete a dog is called, the first thing it will do is to remove all of the feedings and to remove all of the weights and then remove the dog. Or do we want to do that? No, on second thoughts, let's do it within the database, because that means we are only making one hop over to the database for an operation like that. And that makes a lot more sense, to be honest. So yeah, what we'll do now, therefore, is to create an additional migration, which will handle that, which will tell the dogs table to cascade deletes to the feedings and the dog weights as well.
Oh, Mr. T. Welcome. Welcome, Mr. T. You come to assist? I know. You're very happy. Okay.
Well, that's a doghouse full of refactorings right there. But it puts us in a great place for developing the user interface in the next episode. However, that's enough for the time being, so let's pause for coffee. Let's talk about something we don't say out loud enough. Trying to maintain work-life balance and grow as a developer is hard. Really hard. Especially when that growth isn't even specifically for your job. It's for you. Learning Rust, reading research papers, building side projects. None of it's on your company's roadmap, but you do it anyway. Why? Because you don't want to stagnate. Because you know no employer will future-proof you. That's your job. And there's the paradox. The better you get, the more you realize how much more there is to know. So you start trading off. A Netflix binge becomes a crash course in ownership models. Your free Sunday spent debugging some other person's library. The way I get around it is to timebox what I'm doing during the day. It's been turned on its head recently because I'm doing this channel, and learning how to edit, grade, and produce videos alongside the developer learning takes time. But I'm reaching a point where I can do my research, recording, and editing early morning, typically between about 7 and 8:30, so it doesn't impact my day job, and, perhaps more importantly, it doesn't impact my evenings. This may not work for everyone, and perhaps you'll want to drop in some larger slots during the weekend. But if you're strict with yourself, you get time for learning and time for family, friends, and pursuing other hobbies, which is about the most important thing to remember. As always, please like, comment, subscribe. It's still early days for me, and I appreciate any feedback. Okay, so for this last session, I want to finish off the refactorings, setting up the database so we can do the cascade deletes, and then adding all the remaining endpoints that we'll be making use of that functionality.
So let's bash out some code. Migrate. Okay. Okay, we're just copying all of this stuff into the same place just for reference purposes. Drop constraint. That one. And then all to table feedings. It's the same one there. Add constraint. Foreign key dog name references dog's name and on delete cascade. And we want to do the same for the wait time series. Dog waits. Drop that constraint. Re-add it. Foreign key dog name references dog's name on delete cascade. That is what we want. So that gives us the two constraint updates that we want to run. Let's do SQLX migrate run. And there you go. Migration is applied. All looks good. So close that down. And now I need to look at my main.rs and see what I'm missing. So we want insert dog by name, delete dog by name, insert feeding for name, delete feeding for name and time. Cool. Struct. So we create dog payload. Fine. Okay. That's good. Oh, tell you what, I'm not going to get into this now, but really the handlers are for the API implementation, and therefore the types that come in and out of them are the DTOs. What they should be doing is creating a domain type or set of domain types from the DTO as required, and then calling into a repository, passing in just the domain types, and then the repository itself knows about specific types it needs for accessing within the database. So we're kind of muddling up our database repository and our handler here. It is what it is. Pub async function insert dog. What do we call it? As with all of these, it's going to have this first. Hello. Okay. We will implement the into response trait like so, and that gives the outline for our function. I don't know what I did there. Let's get rid of that. Insert into dogs.
name, breed, dog, was it? Values, name, payload dot breed, dog. So that's giving us the way to insert the new dog. And then we want to chain onto that, inserting the initial weight for the dog. $1 for the name, $4 for the current weight. Well, you bugger. This here but I don't want this to be public. I want it to be private. Oh, it's using a transaction. Do we need to have a transaction? Yes, we do, because if this second part fails, we want it to unwind the first. So that's fine. So we're saying insert into dogs, name, breed, date of birth, 1, 2, and 3, name, breed, date of birth. Execute using the transaction, the mutable borrow, and then using an await question mark, which will return a result upon failure. Then we do the second query, insert into dog weights, date, weight, dog name, current timestamp, and using initial weight and the name to pass into that. Again, using the transaction. If we get to this point, we can commit the transaction, and if that succeeds, then we return OK of unit. And then this changes to say create dog with weight. Pool, comma, payload dot dot await. Match result with OK of unit. Then we are returning status code no content into response, which is fine. Otherwise, it's an error, and you return internal server error, which will do for now. So that is insert dog. Screw the transaction. Let's get rid of transactions. Delete dog. Okay. So that's the dog related stuff. Okay. So post to feedings, insert feeding for name. Like so, time for dog backgrounds.
We are getting there. Need dark. Delete feeding. Time is middle. Axum. Delete from beans. Equaling equals 1. And feeding time equals 2. So first one is something. Input time. Which should do it. Yeah, I think it's fine. So that seems to do everything. Amazing. Okay, so something like that. Try sending that request. 200, okay. And there we go. Kuma came in, and it should have a default weight as well. Kuma, there we go. Nice, so that worked. I should be able to add a feeding for Kuma. $200. So if I go here and get dogs/Kuma, Bernie's current weight is 56. There's the date of birth, and it's got 9 a.m. feeding, 1,200 grams. Brilliant. So let's add another feeding. We can see that, and then I'll try to delete that feeding. Should just be able to do that. No, I didn't like it. I don't know if I was expecting 1, but got 2. If I have multiple path params, I need to have but this seems cool. So back to here, send request, 200, okay. Lovely. Go back to here. It hasn't deleted it. Right. Is it called feeding time? No, it's not. So why isn't that an error? That's weird. That should be an error. Okay, cool. So that deleted that time, that feeding, And now the final one is to post, nope, to delete /Kuma. Sorry, Kuma. And that should cascade delete, so we should see the feedings disappear as well. And the weights. So if I look in here first, so if I look into feedings, there's a feeding for Kuma.
If I look into dog weights, there is a dog weight for Kuma. And then obviously in dogs themselves, we have Kuma there as well. So if I now go here and delete Kuma, get to 200, okay. If I go here then and get all dogs, we just see CS dog and T dog. If I look here, there's only 2 dogs there. Look at dog weights. There's no weights for Kuma. If I look in feedings, no feedings for Kuma. Brilliant. I think that is everything. Well, that took some doing.
Okay, so we didn't quite make it. We didn't get to the point where we had Docker Compose and the stub user interface in place. So we'll leave that into the start of the next episode. However, I think this has been valuable because whilst it's just mostly been refactoring, it's just looking at the different ways to implement the APIs and how to use SQLX with the different types of queries that we might want to use, and how to set up Postgres and that sort of thing. So I feel like I didn't want to cut anything out of what I've already recorded here. But again, I don't want to end up creating a 3-hour video for this. So we'll end it here, just looking at the refactorings. And as I mentioned, at the start of the next video, we'll look at introducing the user interface and the Docker Compose stuff.
If you enjoyed the episode, I'd really appreciate you clicking on the like button. It lets me know that real people are watching. If you want to see what happens next, click subscribe and hit the bell for notifications. I'm aiming to get new videos out every fortnight. Until then, and as always, thanks for watching.
Captain Scrunch, what are you doing in the water, huh? And Mr. T. Yeah, was that worth the journey?